Hello, discrete math fans. Now let's talk about the existential quantifier. So the symbol that we're going to use is this guy right here. Looks like a backwards capital E, and that's because it is a backwards capital E. And that denotes there exists. It's called the existential quantifier. For example, if we have a sentence like, there is a computer in room 123, we could rewrite that as, there exists a computer C such that C is in room 123. We could make this a little more formal. We could say, if capital C is the set of all computers, then we could write, there exists a little c in capital C such that little c is in room 123. Now, just like with universal quantifiers, we need to specify a domain for predicate variables when we use existential quantifiers. Now, there are lots of other ways to write there exists. Here are a few ways. There is a, or we can find a, or there is at least one, or for some, or for at least one. So there's a variety of ways that we can express there exists. We don't always want to stick with the same language all the time, and you might see different phrasings in other books. Here's a formal definition of an existential statement. So we'll let Q of x be a predicate, and we'll let D be the domain of x. An existential statement is a statement of the form, there exists x in D such that Q of x. It is defined to be true if and only if Q is true for at least one x in the domain. And if Q of x happens to be false for every x in the domain, then we're going to say that the existential statement is false. And we're going to see lots of examples of existential and universal statements coming up. Okay, that's all for now.